Okay, let's look at example 1, graphing rational numbers. First of all, we have to talk about what a rational number is. I haven't really mentioned a rational number yet. Rational numbers include all integers. And if we remember from before, integers are all positive and negative whole numbers and zero. Integers are in the rational number group. But also included in rational numbers are positive and negative fractions and decimals, as well as other numbers, but we're going to be focusing on fractions and decimals, both positive and negative. In this example, we're going to focus on how to graph a fraction on the number line, how to locate where the point would be at on the number line if it's a fraction. And these two definitions at the top are really long definitions. I'm going to read them to you, and then I'm going to try to paraphrase what they mean here. It says, if b is not a non-zero whole number, and the unit fraction 1 over b is located on the number line by dividing the segment in between 0 and 1 into b segments that has 0 on its left point, the right end point of this segment corresponds to the unit fraction 1 over b. And it says the fraction a over b is located on the number line by joining segments of length 1 over b, so that 1, the left end point of the first segment, is 0, and 2, the right end point of each segment is the left end point of the next segment. The right end point of the last segment corresponds to the fraction a over b. Now, using that, we're going to locate and graph the number 3/10 and its opposite on the number line. To make it a little simpler than what those long definitions were, in order to graph a fraction of any kind, what you need to do is first of all decide what integers is it between. 3/10 is in between 0 and 1. Those are the two integers that are on the outside of both 3/10. If I wanted to first find where 1/10 would be, we're going to say that 10th would be like that b that they mentioned. That tells us we're going to divide the spaces between 0 and 1 into 10 equal spaces. So to do that, I would go like this. Then each of these segments would be worth a value of 1/10. This will be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then of course one whole is equal to 1 or is equal to 10/10. Now this 3/10 is that example where the numerator is the a, not a 1, and this bottom number is our b. Since we already have this space divided up into segments that are 1/10, we then start from the 0 and work our way to the right and count off those segments. So we'd have 1/10, 2/10, 3/10. 3/10 would be right there on the number line. Now, sometimes you can look at that and you can estimate where it's at, but if you have to actually give it exact, precise location, you need to divide up the space between integers and then plot them. And we also have to apply its opposite on the number line. Well, the opposite of 3/10 is going to be negative 3/10. Notice the negative 3/10 is between the 0 and the negative 1. We're going to split that up into 10 equal spaces. That would mean each of these segments would be worth 1/10. But since we're starting at 0 and we're going to the left one segment, we'd have a negative 1/10, a negative 2/10, a negative 3/10, negative 4/10, negative 5/10, negative 6/10, negative 7/10, negative 8/10, negative 9/10, and then negative 10/10 is equal to negative 1. We would start from the 0, we would go 1, negative 1/10, negative 2/10, negative 3/10. that's where the opposite would be. They're opposites because they're the same distance from 0, but in opposite directions.